In this video, we're going to go over the methodology behind the stairs video that I made previously. There are some things that I wanted to explain, and I wanted to give you a behind the scenes understanding of what all went into it and why. First, let's talk about division. If you've done math in school, basic math, then you know that when you divide one number into another number, you either get a remainder or you don't. If you don't get a remainder, then that means that that number goes into the other number evenly. If you get a remainder, then that number does not go into the other number evenly, and there's a certain amount left over. That certain amount left over is what causes issues with alignment in Second Life. Now, your Second Life's not doing division. It doesn't care where you put a prim. It doesn't care what size it is. It doesn't care what the grid unit is. All of those things have to be controlled by the person and understood. And so the harmony between them has to be your responsibility, because Second Life doesn't care. It's just a virtual environment with tools for building. It doesn't care one way or the other whether you have alignment or not. And so you have to be on top of your game and have a system down that actually works to facilitate what you're trying to do and get alignment. And so the harmony between the grid unit, position of prims, and size of prims is going to determine whether you have perfect alignment or not, and whether what you're trying to do works. So, knowing that, let's explain the other aspect of it, the pattern that I mention sometimes. The pattern is whatever pattern you decide to use for building. That pattern is going to be a multiple of your grid unit. If I take this grid unit, whoops, didn't mean to cut it, I meant to copy it. If I take the grid unit and I plug it into my calculator, right? I just hit plus and keep hitting the equal sign. It just increments up, right? It just keeps incrementing, and you can see the pattern. The pattern is 0, 25, 50, 75, 0, 25, 50, 75, 0, 25, 50, 75. And the importance of the pattern that you choose to use is that it eventually ends up being a whole number. For instance, if you used 333, it will never be a whole number. It's always going to have some sort of a decimal. It never goes to a whole number. And because of that, it's never going to work. So you choose a grid unit that is a certain fraction of a whole number that is evenly divisible to a whole number, so that you can achieve what you're trying to do. And then once you decide what that grid unit is going to be, whether it be 0.025, 0.01, 0.25, 0.5, 1.0, whatever it is, you want to make sure that that can always go into a whole number evenly. And then you use that then to determine what your pattern is for your positions and sizes. The pattern being the multiples of the grid unit that I showed you with the calculator. My pattern that I use is 0, 25, 50, and 75. 0, 25, 50, and 75. And so that 0 is the whole number, and the 25, 50, and 75 are the equal divisions between that whole number. So position and size have to be in line with that grid unit to work, and that's why I stress it so much. Okay, so enough about that. When I first set about making the demo, what I did was I made the floor prim, which is what I usually do first, and it was on the ground, and I decided, well, I'm going to do this in the air, so I set it up to 1,000 meters on the z-axis, position. And so it went up to 1,000 meters, and then I came up here and I decided I'm going to make the second floor, but it's going to be smaller so I can demo the stairs. And I decided I'm going to make it 4 meters above the floor prim. And that's a whole number, 4 meters. And I chose that number for ease of making the stairs. I could have chosen another number in the pattern. I could have chosen 3.5 meters. I could have chosen 3.75 meters. I could have chosen 3.25 meters. But I chose the whole number because I knew it was going to be the one that evenly matched the whole pattern, the whole number. So I set it up for the whole number, and then I set about making my first stair prim. And all I did was dropped a box down. I set it for 2.5, and then I decided that I wanted the stair to be in line with the ceiling surface, which is this face right here, and the floor surface, which is this face right here. And so I aligned my first stair so that the top of it was in line with the ceiling face. And then I moved down from there. And because I used the same size stair height on the z-axis as the floor prim height, and because the distance between the two was 4 meters, then it all matched up. But then again, we have to understand that the center is the actual position of each prim. So that has to be factored in as well, especially if I want the faces to be the boundaries between the stairs. So the stairs start right here and they end right here. So I had to factor that in. I didn't think about it when I was making it, and it came out just right. But the center, I knew the center, if I wanted to align it this way, it was going to take that into effect and cancel out a half meter, because you have a half meter height, but the center is, or from the center to the surface is half of that, which is 0.25. And then if you take 0.25 from each of them, it's going to be 0.5, taken away from the total 4 meters, which is the distance between here and here. And that's why I made this prim, to show you that the actual distance between the ceiling surface and the floor surface is 3.5 meters, whereas the actual distance between the floor prims is 4 meters, as shown with this prim here that I never used in the previous video, but was there. You can see the halfway point there, where the center of the prim is. So anyway, because I used the rules, the formula, the pattern, it all came out exactly as I wanted it to. So that's the video. See you on the next one.